Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the paper 4 mechanics, May June 2024, paper 42. Let's take a look at the first question. A cyclist and bicycle have a total mass of 72 kg. The cyclist rides along the horizontal road against the total resistance of 24 Newton. Find the total work done by the cyclist to increase his speed from 8 meter per second to 16 meter per second while traveling the distance of 100 meter. Okay, so over here, we can have a diagram over here. You are having a total of 100 meter. Speed at the beginning is x, and when you reach to the end, it will be 16. You are going to these directions. Okay. So if you, since they mentioned to find the total work done, so we have the conservations of energy. We have the work done by the cyclist is equals to the KE gain plus the work done by the resistant. Okay, so the KE gain will be the half m, the V square minus the U square. The work done by the resistant is the resistant force multiplied by the total distance that traveled. So over here we have m is 72, the V is a 16, the U is 8, the resistance FR is 28, and the distance is 100. So just press the calculator and you get the answer as 9712 joule. Done. So this is the answer for the question number 1. Now we move on to question number 2. Okay, now we take a look at question number 2. A particle P move in a straight line at time t second after leaving the point O on the line. P has a velocity v meter per second where the v is equals to the 40 minus a 6t squared minus a 36. Find the set of values of t which the accelerations of the particle is positive. So in order to find accelerations, acceleration is a dv dt. So you differentiate these equations, you will get 44 minus the 12t. In order for the acceleration to be positive, that means the 44 minus the 12t need to be positive. And just solve the inequality, you will have the t is less than 11 over 3. Just like that, done for the part A. Now we're moving to the part B. Find the two values of t at which the P returns to O. So they say return to O. So for these questions, we want to find the return to O means that the displacement is equal to 0. Okay, so displacement equal to 0, we need to find the x. So we make our displacement as x equal to 0. So to find x, we need to integrate 40 minus a 60 square minus a 36 dd. Then you get a 22t square minus a 12t. No, not 12t, sorry. This one is the 2t cube minus a 36t plus a c. Then when the t equal to 0, your x is a 0. That will give you c equal to 0. So that means your x is equal to the 22t square minus a 2t cube minus a 36t. So when the x equal to 0, okay, so you have 22t square minus a 2t cube minus a 36t equal to 0. Okay, so this x equal to 0. this x is also equal to 0. We want it to be written. That means that at the very beginning one, we do not want it. Okay, so we can just, you can actually factorize it out. I think factorize it out will be better. 11t minus the t squared minus the 18 equal to 0. So the t equal to 0, or the 11t minus the t squared minus the 18 equal to 0. This one ignore, because we already have the t equal to 0 over here already, so we can ignore it. So now the remaining one will be the t squared minus the 11t plus 18 equal to 0. You have t minus 2 and t minus 9. Okay, so therefore, the two values of t that return to O is t equal to 2 and t equal to 9. Just like that, done. That is the answer for the part B. Okay, moving on, we have question number 3. Okay, now we take a look at question number 3. We have a diagram over here. 4 planar forces of magnitude Pn, 10n, 16n, and 2n act at a point in the directions as shown in the diagram. It is given that the forces are in equilibrium. So since the equilibrium, if you resolve the forces vertically, the sum of the vertical force and the sum of the horizontal force will be equal to 0. Okay, so we just do it. Resolving the forces vertically, we have a P is equals to the 2 sine 40 plus the 16 cos 60 cos the theta, then plus the 10 sine 25. Okay, so we not able to do anything over here. I don't plan to press the calculator for this value. I just leave it like that. I do not want to make my value look so messy. I mean, it's messy over here already, but it's just that I do not want to press calculator for these two. I just leave it like that. Okay. Okay. So this is the equation number 1. Then resolve the forces horizontally. I have the 10 cos 25 is equals to the 16 sine theta plus the 2 cos 40. Okay, so by shifting all the value to the one side, then you get this one as a 10 cos 25 minus a 2 cos 40 divided by 16 is the sine theta. Press the calculator directly, you will have the answer as, we can find the theta directly. Yeah, just to get the theta directly, you get 28.08. Okay, so but we want the answer in 1 decimal place for the angle. Okay, so this one is 1 decimal place. Okay, that is the theta. Then from the equation 1, we have the P, just replace it inside. Press the calculator. Then you can get the answer as 19.6 Newton. Okay, that's all. So this is the answer for the question number 3. Moving on, question number 4. Okay, now we take a look at question number 4. A car of mass 1,400 kg, when the speed of the car is v meter per second, the magnitude of the resistance to the motion is kv squared, where the k is a constant. The car moves with a constant speed. Constant speed means the acceleration equal to 0. Okay, then this speed is 24 meters per second up a hill incline at an angle alpha to the horizontal, where the sine alpha is 0.12. At this speed, the magnitude of the resistance to the motion is 480 Newton. Okay, so we want to find the value K. So since the resistance motion is connected to this formula, okay, so that means just say, you just need to say that when the V is equal to 24, okay, your resistance FR is 480. So the formula for FR is K V square equals to 480. So just use your calculator. You can get the answer as K is equal to 5/6. Done for the A part 1. Now we want to go for the A part 2. We want to find the power of the engine. So the power of the engine, we need to understand that the power is actually the driving force multiplied by the velocity. So that means your driving force is actually the power divided by V. Okay, so we need to understand this formula first. Then if you resolve the forces going up the hill, then it will be the driving force minus the weight mg sine alpha minus the resistance force is equals to the ma. So A is 0 because the constant speed. I told you that the A is 0 because of constant speed. So I change this when the V is equal to 24. The acceleration is equal to 0. So your driving force, it will be B over 24 minus the M, 1400, G sine alpha minus the FR is 480 is equal to 0. Okay, just like that. Then just use your calculator. You can get the P is equals to the 51840 watts. Done. This will be the answer for the A part 2. Okay, so now we're moving on to the part B. The car now moves at a constant speed on a straight level road. That means it's horizontal already. Given that the work done, the engine is working at a 54 kilowatt, find the speed. Okay, so now the P is 54,000. Okay, so by using this formula again, your driving force is P over V. Okay, so I think this one I do not need to show this. I just need to show that I'm moving horizontally. So the driving force minus the resistance force, it will be equal to the MA. But this is also constant speed. Okay, so when the P is equals to the 54,000, your A is a 0. So driving force is 54,000 over the V minus the K V square is equal to 0. Multiply everyone by 6V. So if you multiply no need to multiply 6V, sorry. Because equal to 0, I just need to move one side. Again, the V cube equals to the 6 over 5 multiplied by 54000. So just press the calculator, you get the V as a 40.2 meter per second. Just like that, done. So this will be the answer for the question number 4. Okay, and now we are moving to question number 5. We have a diagram over here. A particle of mass 0.8 kg lies on a rough plane. The plane is rough. Inclined at an angle 28 degrees to the horizontal. The particle kept in equilibrium by force of magnitude Tn. This force is acts at an angle 35 degrees above the line of the greater slope of the plane. See the diagram. The coefficient of friction between the particle and the plane is 0.2. Find the smallest and the largest possible value of T. Okay, so we need to consider two cases. So this question actually, if you look at the diagram of the forces, it's supposed to be like this. This is the T, this is the plane, which is a 35-degree here. This is your normal contact force. This is your mass, mg, 8 Newton. This is a 28-degree. So the problem is the frictional force. The frictional force, is it going up? Or the frictional force going down? So that is a problem. But the question didn't mention clearly, so it's possible that the frictional force go up. It's also possible that the frictional force go down. Okay, so both have the possibility. So we need to consider these two cases one by one. So I have the case number one. The first situation is that I assume that the frictional force go up. Case number one. So for the case number one, I resolve the forces perpendicular to the plate. I have the R plus the T sine 35 is equal to the mg cos 28. Okay, so over here, I have my R as the 8 cos 28 degree minus a T sine 35. Okay, so I will consider this as the reaching to the limiting equilibrium because we want to find the least and the greatest possible value of T. Although the question mentioned is equilibrium, but in order to find the greatest and the least value of the T, we need to assume that they are in a limiting equilibrium stage. So our Fr is equal to the mu R is equal to the 0.2 of 8 multiply cos 28 minus the T sine 35. So as usual, I do not plan to press the calculator like that. I just leave it in the form like this will do. That is my FR. So now I still at the case number one, I resolve the forces in such a way along the inclined plane. So I have this T plus the FR is equal to the mg sine alpha sine theta. Okay, so the T cos 35. T cos 35 plus the FR is equals to the 8 sine 28. This one I forgot to mention. This one number one, this one number two. Okay, 1 into 2. I get the T cos 35 plus the 1.6 cos 28 minus the 0.2 T sine 35 is equal to the 8 sine 38. Okay, need to squeeze everything inside. So I rearrange it. All the T I group at one side. Then the rest that is not relevant to T, I put at one side. So this is what I have. 1.6 cos 28. Okay, so just press the calculator like that. Get the T as 3.33. So is this T the least value of T or the max value of T? So over here, actually, this one is the least value of T. Yeah? Okay, the least value of T. How do we know it's the least value of T? So the least value of T means the T value is quite weak. Why weak? Because the T actually need the help of the frictional force to support the particle. So therefore, the force of the T is weak. So we call this one the least value of T. Okay. Then case number two. Case number two, we need to change the directions of still the same diagram. Okay, 35. This one is 28. Then this one is 8 Newton. The only difference is that the force, frictional force now is going this way. Okay. So now the equation number 1 still remain the same over here. Okay. We do not need to find the frictional force anymore. Just use a frictional force from the equation number 1 will do. Okay. So because the only changes is the frictional force. The frictional force doesn't affect the direction of the force of the perpendicular to the plane. So we just need to consider these directions of force will do. So it will be T cos 35 is equals to the FR plus the X sine 28. That will be, I call this one equation number 3. Then I just say 1 into 3. Then I get T cos 35. Oops. Equals to the 1.6 cos 28 degree minus a 0.2 t sine 35 plus the x sine 28 degree. All the t join together. Then I get this as the cos 35 plus the 0.2 sine 35 equals 1.6 cos 28 plus the x sine 28. Press the calculator again, then you get the t is equal to the 5.53. This value, of course, very obvious, is larger than the value just now. So we will call this one the greatest value of t. So at the end, that's all. We have found the t minimum and the t maximum over here. So done. So this is the answer for the question number 5. Okay, so now we move on to question number 6. Three particles A, B, and C of masses 5 kg, 1 kg, and 2 kg respectively lie and rest in that order on a straight, smooth horizontal track X, Y, Z. Initially, A is at X, B is at Y, and C is at Z. Particle A is projected towards B with a speed of 6 meters per second. And at the same instant, C is projected towards B with a speed of V meter per second. In a subsequent motion, A collides and coalesces with B to form particle D. Particle D then collides and coalesces with C to form a particle E, and E moves towards Z. Question part A. Show that after the second collision, the speed of E is 15 minus V over 4 meters per second. So for this question, first of all, we need to have a diagram. This is what happened. This is the A, this is the B, this is the C, and this is the X, this is the Y, this is the Z. A is moving towards B with the speed of 6 meters per second, and C is moving towards B with the V meter per second. Okay, then after that, A and B collide. X is somewhere here. C is here. Then the C is still moving. After they combine, they become D. Then this one is still remain as a V meter per second. And after that, they collide again. So after that, the D and C collide, become E, and they are moving towards the E. Okay, so these are the three situations that describe in the questions. So over here, I think I do not want to make my diagram, don't want to have so many diagrams over here. I just leave it like this will do. Okay, so now what we can do is we need to use conservations of momentum. Okay, so for the first collision, that means the collision between A and B, by considering the principle of conservations of linear momentum, we are having the MA UA, that means the MA UA plus the MB UB equals to the MA plus MB VD. So from here you can get the VD equals to 5 meter per second. So the VD over here is 5 meter per second. That means the particle is moving with the speed of 5 meter per second, and then it will collide with C later on. Now we will go for second collisions, that is between the particle D and C. Still the same, using the PCLM, the principle of conservation of linear momentum. We have the MD. MD is the combinations of the mass of A and B. It will be 6, 5 plus the 2 of negative V equals to the 6 plus 2 is 8 and VE. Okay, so after you collide, then you can, after they combine together, then your VE will be 30 minus the 2V over 8, or you can divide everyone by 2. This is what you get shown. So this is the answer for the part A. Now we want to go for the part B. The total of the CAIE loss of the system due to the two collision is 63 joule. Show that the result from A, use the result from A to show that the V is equal to 3. So what you need to do over here is to find the CAIE at the very beginning. I call this one CAIE initial. CAIE initial at the very beginning, you only have the CAIE for the particle A. Particle A is half mv squared. So the m is the mass of the A. The v is a 6. Then plus with the half mc v squared. So the mc, that means the mass of the C is 2. The speed is remain as v. So it is one, if you simplify it, you get this one as the 90 plus the v squared. Then we have CAIE final. So at the end, the three of the particle combine, MA, MB, MC combine together, and the velocity will be the VE square. So over here, if you simplify it, you get this one as a 4 of 15 minus a V over 4 square. Or we can simplify it, make it become 15 minus V square over 4. Okay, so the CAIE loss is equals to CAIE initial minus the CAIE final. So we know that the CAIE loss is 63. The CAIE initial is a 90 plus V square. The CAIE final is 15 minus a V square over 4. Join together, you will get this one as a negative 27 equals to the V square minus the 225 minus the 30V plus the V square over the 4. Okay, so now I continue over here, multiply everyone by 4, you get negative 108 equals to the 4V square minus the 225 plus the 30V minus the V square. Simplify again, reorganize everything, you get 3V square plus the 30V minus a 117 equal to 0. Divide everyone by 3. Then we factorize it, if we can factorize it. So over here, yes, we can factorize it. This is a plus 13, this is a minus 3. So the V is equal to negative 13 and the V is equal to 3. What is the reason that why we ignore this? Any particular reason why we ignore the V equal to the negative 13? So over here, because you can see that the question mentioned at the end, the VE is moving towards the C. Okay, so in order for the moving towards the C, that means the VE is positive. Okay, so the VE is over here. In order for the VE to be positive, then your V must be over here. This is not the reason. Okay, we ignore this is because this value, if we put this inside, the VE will be 15 minus a negative 13 over 4. The value will be too big already, 28 over 4. It will be 14 meter per second. So this value is too big, not possible. Okay, so the V equal to negative 13 is ignored, okay, because that is too big. So over here, this is the only possibility of the V, okay? So this is what we can have. So like this, shown. Okay, so now we're moving on to the question C. It is given that the distance xy is equal to 36 and the distance of yz is 98. Find the time between the two collision. The meaning of the time between the two collision means the time after first collision but before the second collision. We are looking for the time that is after the first collision but before the second collision. So we need to find how long it takes for you to get the first collision. So in order to get the first collision is between only A and B. Okay, the first collision is only between A and B. So the question mentioned this one is 36 and this one is 98. Okay, so for the first collision, the A is moving 6, but we do not know the time, but it need to reach 36 meter in order to collide with B. Okay, so for the first collision, we are having the 36 meter is equal to the 6 times t1. Therefore, we have the t1 equal to 6 seconds. Okay, so for this 6 seconds, we need to calculate how far has the C traveled. Okay, so the SC, the distance traveled by C, is actually C is moving with the speed of V meter per second, but opposite directions. So since we have found that the V is a 3, so we just multiply VT1. VT1 means SC is equals to the 3 times 6 is equal to 18 meter. Okay, is equal to 18 meter. So after that, that means when the first time A and B collide to become a D, this point is the Y, then the C is over here. C has traveled 18 meter. Okay, has traveled 18 meter starting from Z, starting from C. So this one has been traveled 18 meter. So how much left? The answer that over here remaining is 80 because the total here must be 98 meter. Okay, so the distance between the D and C right now is 80 meter. 80 meter. Okay, so now what you need to do, this is moving with 3. This now is moving with a speed of 5. Okay, so for the SD is equals to the 5T2. Now we are going for second collision already. After the first collision, but before second collision. So 5T2. Okay, then the distance of C from the between the C, the distance of C travel. Okay, over here it will be having this as the 3d2, 3d2. But this C as this C are different because just now this one maybe we can have a second stage. This is the second stage of the C. So the total distance of SD plus the SC2 must be equal to 80 meter because this is the remaining distance left in between them. Then you will have a 5t2 plus the 3t2 is equals to the 80, and the t2 is actually equals to 10 seconds. Okay, so done. This is the time taken. This is the time taken for the particle D and C collide. Okay, so C part 1 done. Now we're moving to the C part 2. Find the time between the instant A is projected from the instant from X and the instant that E reaches Z. Okay, E reaches Z. So what you need to do now is we need to calculate the T2. Okay, what is the SC2? Okay, so SC2 is actually equals to the 3t2. So it's 3 times 10, you get a 30. Okay, so that means what? That means in the D and C, D is over here. After the first collision, the C has traveled 18 meter. Then when they D and C collide, become E, this one has traveled another 30 meter. So this one is 18. This one is a 30. So total is a 48. Okay. So now you are moving with these directions. The distance is 48 meter. Okay. So now the distance SE is equal to the 30 plus 18 because you have 48 meter to reach to the C. Okay. Then our VE is how much? VE is the speed over here. The VE, we are using this value, changing the V become 3. You get 15 minus 3 over 4. 15 minus 3 over 4. So over here, you get 15 minus 3 over 4 is actually a 3 meter per second. Okay. So we need to move from here. This one is 48 meter. Okay. So formula for SE is VE T3 is equal to the 48. It's a 3d3 is equal to the 48. That means the d3 is equal to 16. So therefore, the total time is equal to the d1 plus d2 plus d3. That will be 6 plus 10 plus 16. The answer will be 32 seconds. Okay, so this is the answer for the question C part 2. Okay, done. Now moving on, we have question number 7. Okay, now we take a look at question number 7. Two particles P and Q of mass 2.5 kg and 0.5 kg respectively are connected by a light inextensible string that passes over a small smooth pulley fixed at the top of a plane inclined at an angle 30 degrees to the horizontal. Particle P is on the plane and Q hangs below the pulley such that the level of Q is 2 meters below the level of P. See the diagram. Particle P is released from rest with the string taut and slide down the plane. So the directions of the motion is going down here. The plane is rough with the coefficient of friction 0.2 between the plane and the P. Find the accelerations of the P. So over here, for these questions, we need to resolve the forces at P and Q separately. So at Q, the weight of the Q is 5 Newton and the tension is like this. So at Q, if you resolve the forces vertically, you have the D minus the 5 is equal to 0.58. That will be the first equations. And for the P, the tension is going this way. The weight for this is 2.5, 25 Newton. And the angle over here is 30 degrees. This is the normal contact force. And the frictional force is also going upward. So if you resolve the forces, I forgot to mention at P. So at P, if you resolve the forces perpendicular to the plane, you will get R is equal to the 25 cos 30 degree. That will be 25 sec 3 over 2 Newton. Then your frictional force will be the mu R. It will be the 0.2 multiplied by 25 sec 3 over 2. Simplify it into the exact value form. You will get it as a 5 sec 3 over 2 Newton. Okay. Now, if you resolve the forces parallel to the inclined plane, you will get the 25 sine 30 minus the frictional force minus the tension is equal to the 2.58. So you just replace the 25 sine 3, 25 sine 30 is a 25 over 2 minus the frictional force minus the T is equal to the 5 over 2A. So we can join together, become 25 minus the 5 sec 3 over 2 minus the T is equal to the 5 over 2A. That will be my second equation. So to solve to find the A, just take the equation number 1 plus the equation number 2. Then you will get 25 minus the 5 sec 3 over 2 minus the 5 is equals to the 3A. So just press a calculator. Then you can get the answer as 15 minus the 5 sec 3 over 6 as your accelerations, or you can change it become 3 significant figure. This will be the answer for the question A. Okay, so now we're moving on to the question B. Use an energy method to find the speed of the particles at the instant when they are the same vertical height. So when they are in the same vertical height, so this one will slide down. So this one will go up to the same vertical height. So this is the same vertical height. So this same vertical height, we will assume that this is the h, then this will be the h. Okay, then but we have the height over here is, you have a h, you have a 30 degree, then this one it will be h sine 30 degree. Okay, so this is what we have. So from here, we can have this as the half of the h. And have this as a half h. Okay. So back to the B. So first of all, I think we need to get ready of some of the information first before we start. So let's just copy down the diagram here. This is the h. This is the half of the h. Okay. So we know that the h plus half of the h will be 2. That will be giving you that 3 over 2h as a 2, then h is actually 4 over 3. We need to have this information ready first before we solve the whole problem. Okay. Yeah. So because this height over here is half of the h, and the height over here is h, add together, the total must be a 2 meter. Okay. So therefore, you get a h as 4 over 3. So in order to use the energy method, this situation is a bit complicated because you have two particles moving at the same time. So we can actually draw the table here. To see the situations clearly. We have a kinetic energy. We have the potential energy. And also we have the work done by others. Initially and finally. So at the very beginning, for the P, it has the, it doesn't have the kinetic energy. Okay, at the end, at the beginning, Q, this is for the P, this is for the Q. This is for the P, this is for the Q. Okay, oops. This is the work done. This is for the P, this is for the Q. So at the beginning, your P doesn't have any initially the P doesn't have any KE. Same thing goes for the Q, but at the end here got the kinetic energy at the end. At the end, Q also have kinetic energy. Okay, because they mentioned that they release from rest. Okay, they release from rest. Yeah, they release from rest. Okay, so at the beginning, both P and Q have no KE, but at the end, when you move in the same, they are in the same level of height, then they both have the KE. At the beginning, Q have no intention to go down. Okay, but the P has the potential energy to go down. So, but the P go down, it will be go down with this height, half h, half of the h. Okay, so over here we have this as a MP, G, half of the h. Then at the end, when you reach the same level, then no more. But the Q is moving up, so it will be mgh. To be more precise, I suppose I write mq. Then work done. At the beginning, they both have no work done. For the Q, no work done for anything before and after. So then for the P, we have the work done by the resistance. Work done by the resistance is actually the FR multiplied by the distance at travel, mgh. So by using the conservations of energy, listing out everything, whatever you have in the beginning is equal to whatever you have in the end. So you have the MP, G, half of the H is equals to the, not enough place, so sorry. I think I better use a new line over here to sum up everything. So the conservations of energy mentioned over here is we have the MPG half of the H is equal to the half of MP plus the MQ V square plus the MQGH plus the FRH. So MP is 2.5 times G, 25. Half of the H is a 4 over 3. MP plus MQ is 3. V square we do not know. MQ is not times G is 5. Then this one H is 4 over 3. Frictional force, FR, frictional force Fr is phi Z3 over 2. So phi Z3 over 2. And the H is 4 over 3. Just like that. So we can simplify everything here. Then you get this one as the 50 over 3 equals to the 3 over 2 V squared plus the 20 over 3 plus the 2 times 3 over 3. And then you press the calculator. Just everything that you have over here, just press the calculator. Then you can get the answer as the V is equals to 1.68 meter per second. Just like that. Okay, just like that. Right. So this will be the answer for the questions number 7B. And that will be the last part of this question number 7 and also the last questions for this whole paper. So I will stop the video here. I will see you next time in other video. See you then and bye-bye.